Okay, I just want to finish up this example then. So you can see that you're just pulling out what's left of the equation, or what's left in the matrix itself, and substitute values in to solve. So this one, the y value from above, plus 8/7 t, and then plus t equals -3/2. So we end up with 5/14 minus 8/14 t. I'll make that last t into 14t over 14, and I'll make this one into something over 14 as well. And collecting up like terms, so -8, so we end up with 6t over 14. We'll move that to the other side, it becomes negative 6t over 14. And add 5 to both sides, we end up with -16 over 14, and of course they reduce to 3/7 t, and then the other one we can reduce it to 8/7. So there we go. So there's your x value. So therefore, what's the intersection? Well, there's an infinite number of intersections, and this is how you'd calculate the point of intersection, or the points, I should say. And there are some people, hopefully, that are looking at this and saying it that, and I'll put the or, so this is how you'd have the solution. I'll move homework down for a sec here. Or, and this is an extension because we're not there yet, but they'd be saying, hey, wait a minute, this kind of looks like a parametric equation, and you'd be absolutely correct. This is a parametric equation where there isn't one solution, there's an infinite number, and they actually form a line. And I'm going to talk about that, and that's kind of where we're heading with this. Rather than keep it a big hush-hush secret, you're going to find that in the end, when you have an infinite number of solutions in 3 space, or with the 3 equations, 3 unknowns, it turns out to be a line. Why does it turn out that way? That I'll specifically talk about as we move through. So there we go. So the homework is a handout, and you can print that off, or you can just view it as a PDF. I just want to go back, like I said, as promised. I'm going to go back to that one slide where it has possible outcomes for 3x3 matrices, and it should actually be 3x4, okay? Because we're looking at those scenarios that we talked about. So you could end up with, and again, I'm just making up the numbers here, something that looks like this: 0, 0, 2. So this is an independent solution. Okay. 1 point of intersection. All right. The second possible outcome could look like this. Which one do I want to do? Let's do all zeros. And that row of zeros doesn't have to be the bottom row. It could be the middle row as well. So they could be interchanged. So this is a dependent solution, or dependent system. Dependent system. Okay. Infinite solutions. And we might as well also make the mark solution forms a line. And as an extra note, this is when you let z equal t, where t is an element of real numbers, or any number that you pick. Okay. And then finally, the third outcome here, and again, it could occur in any row. It doesn't have to be the last row. 0, 1, 2, 3, 0, 0, 0, 5. Okay. When you have 0, z equals 5, this is when we get what we call an inconsistent solution or system. Inconsistent system. No solution. We're going to talk about what it looks like graphically. So for the spatial people here, they're trying to figure out what this looks like. It's coming. All I want you to do basically today And like I said, the goal was I want you to be able to solve 3 equations, 3 unknowns. So I want you to be able to do this process right here. All right. If you can get this process taken care of, then when we get to the application section, which is 4 or 5 lessons away yet, I introduce matrices early, so you don't need to be successful with matrices to do the next lesson. There's like a 4 or 5 lesson gap. And what it does, it allows you some time to kind of process and practice this. The handout, I think there's only like 6 questions or 8 questions, but I can find many, many more for you. But it's just a matter of practicing the method, and then we're going to worry about the interpretation after. Okay, so don't get overly frustrated if you're not successful in the first couple tries. Don't get overly frustrated if you're making small mistakes, because again, remember, I'm a process marker. Okay, so I'm looking for that process. So small mistakes don't hurt you in the end. And that homework is in a handout, and you can print that off from my website. Good luck.